we now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. The problem is related to the limit superior of certain sequences. And this question is from the section Real Analysis. This question is from part B, carrying 3 marks, and it has a question ID 704024. The given question is: consider the sequence an is equal to 1 to infinity, where the nth term an is given by cos of minus 1 to the power of n into n pi by 2 plus n pi by 3. Which of the following statements is true? We are given 4 options. Option 1, limit superior n tends to infinity of an is root 3 by 2. Option 2, limit superior a to n as n tends to infinity is 1. Option 3, limit superior a to n tends to infinity is 1 by 2. Option 4, limit superior a3n as n tends to infinity is 0. Let's now discuss the solution of the problem in detail. We have the given sequence where the nth term is given by this. And notice that this sequence is a bounded sequence of real numbers. Why it is bounded? Because every nth term is involving cos function, and we know minus 1 less than or equal to cos x less than or equal to 1 for all x. Therefore, the terms will lie between minus 1 to plus 1, including minus 1 and plus 1. Therefore, it is a sequence of real numbers which is bounded. Agreed. Agreed. So we have the sequence, the nth term is given, and we have already noted that this sequence is a bounded sequence of real numbers. Agreed. Now let us take the option 2, limit superior a to n as n tends to infinity is 1. Option 3, limit superior a to n as n tends to infinity is 1 by 2. Right. So what is a to n? A to n is a subsequence of a and n is equal to 1 to infinity. Consider the subsequence a to n is equal to 1 to infinity, that is a2, a4, a6, so on and so forth, where a to n is cos of minus 1 to the power of n. In the place of n, you have to substitute 2n into 2n pi by 2 plus 2n pi by 3. Wherever there is n, you substitute 2n. And this is equal to cos of, this is n pi plus 2n pi by 3. Take the LCM, then it is 5n pi by 3. So it is a to n is cos of 5n pi by 3. Agreed. Agreed. Consider the subsequence a12k greater than or equal to 1 of a to n is n greater than or equal to 1. Why all of a sudden a12k, the subsequence a12k greater than or equal to 1 of this subsequence a to n greater than or equal to 1? And what we have done is n is 1, we have seen, n is 2, n is 3, n is 4, n is 5, n is 6. Then it is 30 cos of 30 n pi by 3. Then it will be 10 k pi. So cos 10 k pi for various values of k, it will be 1 only. So thus you will get a12k greater than or equal to 1 will give rise to a sequence 1, 1, 1, 1, 1, which converges to 1. Now, A12k, k greater than or equal to 1 is A2.6k. That means in A to n, substitute n is equal to 6k, k greater than or equal to 1. Then that will be cos of 5 into 6k pi by 3. That is cos 30k pi by 3. That is cos 10k pi, k greater than or equal to 1. Cos 10k pi, for any value of k, it will be 1. 1, 1, 1, 1. So, this is a subsequence 1, 1, 1, 1, 1, which is a constant sequence which converges to 1. So, what does it say? What does it say? Thus, a to n, n is equal to 1 to infinity, has a subsequence A12k, where k is 1 to infinity, which converges to 1. So, then what is 1 is called? 1 is a subsequential limit. 1 is a subsequential limit of a to n, n greater than or equal to 1. Right? Right? And you recall a result. If you have a bounded sequence of real numbers a and n is equal to 1 to infinity, capital M and small m are the limit superior and limit inferior of this sequence, then capital M is given by the greatest subsequential limits of an, and the limit inferior small m is given by the least subsequential limits of an. So, what does it say? It says you collect all subsequential limits of the sequence, then take the greatest value, then that will be limit superior. Now, we have calculated one of the subsequential limits of the sequence a to n, n is greater than or equal to 1. But what is our a to n? Is a cos function. So, in this subsequence, the cos will be cos 5n pi by 3. So, subsequential limits will be minus 1 less than or equal to cos of this function is less than or equal to 1. But we have already obtained 1 is the subsequential limits, and that is the greatest of all the subsequent limits, because the other subsequent limits will be less than 1 because it's a cos function. Right. Now, limit superior a to n, n is equal to n tends to infinity, is the greatest subsequential limit of a to n, n is equal to 1 to infinity, and the greatest is 1 because minus 1 less than or equal to cos x less than or equal to 1. That means to say the other subsequent limits will be less than 1. Therefore, the greatest of all subsequential limits will be 1. Therefore, limit superior n tends to infinity a to n is 1. So, the option 2 is true because it is 1. The option 3 is not true because it is given 1 by 2. But the answer is 1. Right. Let's move to the next slide for the other options. We consider option 1, limit superior n tends to infinity, a n is root 3 by 2. And option 4, limit superior a 3n, n tends to infinity is equal to 0. So, we have the given sequence. This is the given sequence. And observe that this A12k, k greater than or equal to 1, what we have considered in the last slide is the subsequence 1, 1, 1, and this is also a subsequence of the given sequence an, n greater than or equal to 1. In this an, wherever there is n, you just substitute 12k, you will get this one. So, this is also a subsequence of the sequence. And you can also observe A12k, k greater than or equal to 1 is also a subsequence of A3n. How do we get it? A3 multiplied by 4k. So, in A3n, wherever there is n, substitute 4k, you will get this one. So, A12k, k greater than or equal to 1 is A3 into 4k, k greater than or equal to 1 is same as 1, 1, 1, 1 is also a subsequence of A3n because it is A3 multiplied by 4k. So these two are, thus you got these subsequences, they converge to 1. So 1 is a subsequential limit of this sequence an, and 1 is a subsequential limit of this sequence A3n. So now you recall this one. Limit superior n tends to infinity will be the greatest subsequent limit of an, that is 1, because the cos x value takes values between minus 1 to plus 1 inclusive of minus 1 and plus 1. And all subsequent limits will be less than or will lie between minus 1 less than or equal to 1. And 1 is the greatest, we have already got it. Therefore, we are not worried about what are the other subsequent limits. Now, limit superior n tends to A3n, same, the greatest subsequent limit of A3n, that is 1. Right. So, that means the limit superior of the given sequence and limit superior of the subsequence A3n, they are all one and the same, and they are 1. But it is given to be limit superior of the given sequence root 3 by 2 and limit superior of A3n is 0. And therefore, limit superior n tends to infinity an is 1, limit superior A3n n tends to infinity is 1. Therefore, your options 1 and 4 are not true. Option 1 is not true and option 4 is not true. Agreed. So, therefore, what is true? The answer to this question is option 2. Right. Limit superior n tends to a to n is 1. That is your answer. And that is the detailed discussion of the solution of the problem, which is based on the limit superior of certain sequences. Yes. I am sure that you have understood the solution of this problem, and I make an appeal to all the viewers. Please like and share my videos if you like my lecturing, and if you like my way of presentation, please do it. I request you to subscribe my channel and suggest to all your friends and relatives, whoever interested in mathematics, to subscribe my channel and share the videos. I wish you all the best. Thank you.